In a remote part of the world, an unmanned aircraft flies undetected over a small village, believed to be a terrorist stronghold. Using advanced sensors, the UAV scans the terrain. Images are beamed simultaneously via global satellite to the United States Forward Command Post, to a networked command and control vehicle over 15 kilometers away, as well as the U.S. Central Command thousands of kilometers away. Armed with information and data from its global positioning system, the Forward Command Post repositions its brigade combat team and surrounds the village. A team of robots and unmanned aerial vehicles move in to target the enemy. A battle plan is drawn. Through the network, Apache helicopters are called on to strike the designated targets, while computer-guided, non-line-of-sight mortars also rain in fire. The terrorists are quickly on the ropes. As armored infantry vehicles enter the village, images from the unmanned aircraft reveal the enemy's every move. Using its Blue Force tracking system, the commander scans the battlefield and sends in troops to secure the site, while calling in close air support. Joint Strike Fighters launch guided missiles on a nearby weapons cache. The enemy has been found and destroyed with unparalleled precision and coordination. Is this some futuristic fantasy? Not at all. It is the army of today. This is the new technology of war. What will warfare be like in the near future? Gone are the grand illusions of colonial gentlemen and kings. We are now far beyond the nuclear deterrence of a mutually assured destruction. There's a new paradigm with new systems and new science to fight a whole new kind of war. This is the cutting edge of combat technology. Welcome to the front lines of the future. It is a new day in the field of battle, a dark one. They call it asymmetrical warfare, meaning threats from all directions and outside the range of conventional fighting, threats that are often difficult to respond to. Our enemies in the future will be unpredictable and elusive. To win these conflicts, the tools of combat will have to change.
What we're likely to see over the next decade are a lot of conflicts like we're having right now in Afghanistan and Iraq, where we're facing a dispersed enemy mixed in with the general population, and we have to determine how to apply force in that situation to get the effect that we want. We have to prepare for the full spectrum of battle in the future.
The perils soldiers face today are reinventing the military of tomorrow and launching a new age in the science and technology of warfare.
The idea is to make things cheaper, faster, more lethal, with fewer people. Those are the principles of transformation.
What are the high-tech weapons of the new army? How do they work? How will they work together? Step onto the battlefield of the future and find out. Technology is stepping up to change how wars are fought and won. The day is soon coming. In fact, it's already here. Led by the United States and allied defense industries, weapons, transport, and information systems, innovations that are using breaking science are already being fast-tracked on the ground.
We are engaged in the development of transformational capabilities for the Army right now. We are going from a traditional set of fighting vehicles, an M1 tank, a Bradley, Humvees, to a system of systems, much lighter weight vehicles, insertion of a lot of robotics capability, insertion of new sensor and communications capabilities into those systems to operate differently than we have in the past and manage our assets in a way that we have not done in the past.
But real war is no video game. How can machines know where to aim? How can remote control armies be pointed in the right direction? The answer will take an advanced technology, one that you'd think is the stuff of science fiction. The U.S. Army's vision beyond is called Future Combat Systems. This system networks existing operations with systems of tomorrow to form what the Army calls its Brigade Combat Team. It will be light, mobile, and easy to deploy. And it will be more technologically advanced than anyone could possibly have imagined just a few short years ago.
This is a generational leap of precision weaponry. It's 18 very high-tech systems, plus the soldier, plus the network that controls all of the 18 systems.
These 18 high-tech systems will include ground sensors and munitions, launch systems and intelligent munition systems, unmanned air and ground vehicles, and manned combat systems. All will be joined together by an ultra-high-speed worldwide network at the fingertips of commanders in the field, which will filter down to the ultimate sensor, the soldier.
It's the ability to have that precision munition fully integrated into a total package that the soldier forward is seeing, is perhaps ordering a strike, that his commander has ordered that strike, and all of the repercussions to that particular action are felt throughout the entire battlefield.
In fact, part of the network is already up and running. Like any good army, the forces of the future will have to move in lockstep. Every device, every soldier must be in sync. Global Positioning System, or GPS, is the linchpin to the military's high-tech revolution. Using 24 orbiting satellites, GPS casts a virtual grid across the planet to calculate a person's exact coordinates on the map.
It's always been a question to know exactly where people are, and to that extent GPS has been very useful. What we really want to do is validate our intelligence. Is the enemy where we thought he was? When do we come within a particular weapons range? Indirect fire, direct fire, and so forth. If we are now going three-dimensionally and we want to add close air support or fires, we have to have a good appreciation for where our forces are so that we don't commit fratricide. And at the same time, what we want to do is we want to mask the effects of those fires at the appropriate place and time. That's the kind of information that allows us to gain momentum with our operational maneuver.
Radio signals are bounced off 4 satellites, and where the 4 signal relays converge can be pinpointed, even down to a centimeter, clocking the exact location of anyone, anywhere. Soldiers and machines can orient themselves on the global grid to take stock, take cover, take aim.
I can have a unmanned air vehicle flying 10 miles away from the battlefield spot a target. They can relay their video imagery to a control room on the other side of the planet. They can get global positioning system coordinates for the specific target, radio those back to an artillery unit that would be 20 miles away. They can fire a precision munition onto the target, and you can accomplish with a single artillery round what in the old days would have taken dozens of artillery rounds, and never get close enough to the enemy that the enemy is going to be able to see you.
GPS is technology today, but there's more to this high-tech arsenal still under wraps. The Army of tomorrow isn't going to let a soldier out of its sight. In the near future, a singular technological breakthrough will see to it that commanders can keep tabs on every soldier's whereabouts. It's called Blue Force Tracking.
Blue Blue force tracking is basically having communications and electronics in our systems that allow us to track where all the blue forces are. Blue forces we normally talk about are our friendly forces, ourselves, our coalition partners. Red forces are the enemy. We're able to track where all of our individual vehicles are, at least in some cases our dismounts, and be able to tell where they are on that battlefield, put them on an electronic map and be able to see, okay, these elements are here, these elements are here, and make sure that we've got them best deployed to accomplish a certain mission, but also track so that if we start to see some sort of problem where, okay, this element is moving into an area where I'm expecting this element to attack, I can provide that information to them and limit the potential for fratricide.
Using GPS technology, and by embedding a powerful homing device in each uniform, soldiers can be fully accounted for. The data is beamed to every secure screen, from headquarters down to the boots on the ground, so there's no mistaking the good guys from the bad. That's something Captain Bart Hensley learned when he put Blue Force tracking to the test in Iraq.
Probably the hardest thing about battle tracking is knowing where all your personnel are. Otherwise, it would be me with a radio and a map trying to visualize where all my people are located based on what they would be telling me over a radio. Now all I have to do is look at a screen and I can see. September 2004, our brigade launched an attack into the city of Talifar, which is about 30 miles west of Mosul. And essentially, my company was the battalion main effort, and we had several positions that we had to occupy, which we were able to do successfully during hours of darkness. Once the sun came up the next day, the situation changed dramatically. The enemy came out and actually began to engage us from long range, started dropping mortars on us, and became a very fluid environment. So what I had to do was start repositioning my platoons around the battlefield. And again, it came back to, I'm giving them instructions where to go. I've got to check my map, and it was amazing how each time it was like the plan kept coming together. Every time I was giving the orders, instructions, my guys were executing. I was able to look at the map and pinpoint that, yes, in fact, my guys are at this location. This is what they're reporting. And what that did was allow me to send accurate reports to my higher headquarters based on, the reports I was getting from my guys, as well as the feedback from all the sensor suite we have.
The key is having something to track, a beacon that never leaves the body. The military's secret weapon? Miniature computers are changing the way we go to war.
High-performance computing will be embedded in everything around us. It'll be embedded in the soldier uniform. It'll be embedded into ground vehicles, whether they're manned or unmanned air vehicles. It will be everywhere. It'll be ubiquitous. Now, the impact that has is in the processing of information, being able to process large amounts of information in shorter and shorter periods of time.
In 1965, Gordon Moore, co-founder of computer chipmaker Intel Corporation, made a radical prediction that the number of transistors per square centimeter on integrated circuits will double every year. 40+ years later, Moore's law has been proven right, year in, year out.
The last several decades of military technology have simply been a commentary on Moore's law. We continue to miniaturize electronics for computation, to miniaturize digital cameras, to miniaturize other sensors. We continue to be able to do more with less at the microscopic level, and consequently be able to do more with less at the macroscopic level as well.
Right now, time definitely matters.
Miniaturized high-performance computers are making possible military technology hard to imagine just a few years ago. Technology that provides both a tactical and a strategic superiority to help keep fighting battalions out of harm's way. And the technology is upgrading hardware, both large and small. Take a look at the next generation of high-tech combat vehicles. Speed or power, that's the choice when it comes to armored vehicles. You either get the bang of the Abrams or the vroom of the Humvee. But if your life's depending on it, that's no choice at all. To stay superior on the ground, both speed and power are essential. So how can military engineers combine them in one monster machine? They already have. Step one has been to soup up the old reliables. the Army is retrofitting every current combat vehicle with the latest digital technology.
The biggest thing that happened to the Abrams was the digitization of the tank. From the A1 model to the A2, we went from the old style analog wiring harness architecture to a digital data bus. All the systems in the tank run digitally from operating computers. Shortly after that, we did the same thing to the Bradley fighting vehicle. These are very software-intensive systems. There's actually more lines of code in an Abrams tank than there is in an F-16 fighter.
But retooling tanks is not enough. With battles flaring up in every far-flung corner of the globe, mobility is key, and an Abrams or a Bradley could take days to arrive on the scene. Enter the Stryker. It's a first step towards realization of the future combat systems, a vehicle designed for 21st century combat on the front lines today. It can carry over 3 tons of cargo, nearly 3,000 kilos, and pull 5 tons more. Its 350 horsepower engines can deliver speeds over 100 kilometers per hour. And it can be any place on Earth in 96 hours or less. When the Stryker arrives, it makes its presence known.
We call it a capabilities platform. It's both lethal, mobile, and combines the latest technology that the Army's gathered. All right, so what it can do is protect soldiers moving, in and about the battlefield under hostile conditions. But then, unlike a mechanized unit, when we dismount, we have a full 9-man squad getting out of the back, as opposed to maybe only 4 or 5 soldiers in a mechanized unit. The tanks and Bradleys are great out in the desert. In Desert Storm, we proved that that was a valuable asset. But now, when you're talking about operating in some of the cities, which we didn't do in Desert Storm, now the Bradleys and tanks are not as effective. While they have great sensors and can do a lot of things for us, they don't have the infantry capability that the Stryker Brigade is known for. We're an infantry-centric organization, which means we're formed around the core infantry squads, whereas the heavy units do not have enough manpower to get boots on the ground, essentially, where we do. On top of that, it's equipped with the latest sensors and capabilities on the RWS, the gun system that we have that sees in the thermal spectrum. It gives us a great capability at night, and then obviously just the speed with which it can travel on the highway and even off-road. We get to places where we need to go quickly, but also quietly. One of our first big operations was in Samara. We'd only been in country maybe about 2 months. We hadn't been in Samara but about 2.5 weeks when the locals started referring to us as the Ghost Riders. The reason being was the unit that was there previously was a tracked unit with Bradleys, and you can hear those things from miles away, whereas us, they would not know we were coming until the ramp hit the ground and our soldiers were getting out into their backyard.
It lets us get to the fight a lot faster, a lot quieter. It sped everything up quite a bit.
Like driving a car, only, quite a bit bigger. It's got a regular steering wheel. It's got a gas pedal, brake pedal. Your seat reclines just like a regular car. You have a speedometer, gas gauge, all that good stuff. It's all right there in front of you. The engine in it is a 3126 Caterpillar inline 6. It's turbocharged with 350 horsepower. As the vehicle sits right now with slat, it weighs in at 21.5, 22 tons. Without slat, it's 19 tons. Either way, we can get 70 mile an hour out of it. 68 because it's governed. So, and I've heard that if you take the governor off, you can do up to 80. That's the biggest thing on this vehicle right here is the shocks. It's hydraulic over air, and the front 2 wheels and the rear 2 wheels on each side are connected, so whenever you hit a bump, the first wheel gets pushed up, the second wheel gets pushed down. That way it tries to maintain contact with the road, whereas tracked vehicles just have, gas piston shocks that are real rough. There was one instance where we were driving down the road, the streets were quiet, and then the kids and children and the women and everybody just started disappearing off the streets, and then everything got tense. We were like, when's it coming? And the next thing you know, you're a loud pop, and it's an RPG going by you. It's a huge security blanket because you hear bullets just bounce off of it. RPGs, if they hit, they really don't penetrate the vehicle. Some of them even glance off. They've been known to glance off the vehicles. So you just know that pretty much nothing is really going to hurt you for that time being, unless they come up with something bigger,
What's really novel about the Stryker is its versatility. Currently, there are 10 variants. Its chassis can be adapted to carry troops or pack a punch. More than 2,000 Strykers are slated to roll out in the coming years in 6 brigade teams. But they're just for starters. There's still room for improvement. Protection takes armor, and that adds weight. An Abrams tank weighs in at 70 tons, or about 63,500 kilos. A Stryker, just 19 tons, 70% lighter. How can an even leaner, lighter, faster tank of the future stand up to the pounding? The answer is by being quicker on the draw. It's called active protection, a new technology that will sense incoming fire and stop it in its tracks.
We're going from a very heavy class of vehicle where the protection of the vehicle is through armor to much lighter vehicles where the defense systems are more electronic. There is a base of armor, but we're protecting the vehicle with a combination of electronic warfare and active protection systems, which allows you to get a level of protection that is actually a higher level of protection than what we're getting today in the current fleet.
Active protection systems sense incoming fire and proactively respond. They send fire against fire, destroying the incoming round before it has a chance to hit the vehicle. The system will use radar sensors, jammers, and decoys to disrupt the guidance system of the incoming long-range missiles or guns. If that fails, the hard kill sensors will detect the incoming target and will move, point, and fire countermeasure rockets, all within a split second. What's good for the machine should go for the soldier as well. Technological advances in body armor have been dramatic. What use is body armor if it just weighs a soldier down?
In Vietnam, a vest weighed approximately 30 pounds. It was ballistic nylon. It only stopped fragments from grenades or whatever, shrapnel, and it weighed 30 pounds.
Soldiers today are wearing half that weight and getting a lot more protection.
On the Interceptor OTV, the outer tactical vest, the vest without the plates weighs approximately 8 pounds. That's the ballistic material and the carrier. The ballistic package in the vest is rated to stop 9mm pistol rounds and fragmentations. Then when the small arms protective insert, the SAPI plates go in there. The plates offer protection against various 7.62 rounds, 5.56 rounds. That entire combination weighs approximately 16 pounds. So in the Vietnam era, you had a vest that weighed 30 pounds that only stopped fragmentations. In today's world, you have a vest that weighs 16 pounds, I should say a system that weighs 16 pounds, that now stops fragments, pistol rounds, and high-velocity rifle rounds.
The secret to the vest's success? Special fibers that are as light as cloth, but 10 times stronger than steel.
Spectra Shield has a very unique property that's called viscoelasticity, and basically it allows it in a ballistic event to, from a monolithic solution standpoint, it stops high-velocity rifle rounds at lower weights than other materials. So the faster the bullet, the higher the velocity, the better Spectra Shield performs versus other materials.
We are taking this fiber and we are aligning it in a process where we have multi-filaments, many ends of this material, all laid up and spread out. So what we get is a very uniform, very thin web of fiber filaments. And then we kind of glue it down with a very small amount of glue, so you can see that they stay in place. They only stay in place for us long enough so that we can take 2 webs of material and cross-ply them. What we do then is apply temperature and pressure, and we end up with a material that is very strong.
During World War I, the grim reality was that for every 3 combat injuries, 1 was fatal. With the invasion of Iraq, the survivability rate has improved to 8-to-1. Body armor is one big reason for that. In fact, apply it, and its properties are just enhanced.
This is what's used in the backing of the SAPI plates. A ceramic is applied to the front surface of this, and then we have this as the backing material associated with the performance. So SpectraShield is the key stopping power behind the ceramic, does all the energy absorption associated with the projectile.
But what about the fabric of the future? A soldier today may carry as much as 140 pounds. How can he be sleeker, yet even more secure against attack? To find out, go molecular. The breaking science of nanotechnology allows scientists to build molecules from the ground up, manipulating structures as small as a billionth of a meter, or 1/1,000,000th the size of a pinhead. The result, unique compounds that can actually sense what's around them and adapt on cue.
We're in a stage in our understanding of atoms and molecules where we're trying to build materials from the atom up. And one could approach that from an experimental science, where you try to mix materials in ways in which you may stumble on materials with unusual properties. But the real hope is that through a real understanding of atomic and molecular interactions with large collections of atoms and molecules, we can understand them so well that we could predict the properties in advance and actually tailor the properties in ways in which it'll suit and optimize particular applications that we're looking for.
At MIT, at the Institute for Soldier Nanotechnologies, they are working on these supermolecules of the future, which can be used for a variety of purposes.
The materials we've brought today are, they're called conducting polymers, and it's electrically conductive, like a piece of copper would be. So you can use it simply as just a wire to connect two circuits. You can also use it as like a displacement monitor. And then finally you can also use it as an actuator or a contracting material. So were you to apply a voltage across it, approximately 3 volts with 20 to 50 milliamps, you can create a stress 100 times greater than human muscle. And so the idea is you can build an exoskeletal muscle that could assist in maybe a tourniquet.
Nanotechnology is delivering on the ultimate dream of combat. A suit of armor as impenetrable as steel, as supple as silk, using a new compound called liquid armor.
As you imagine, I have a pointed object going into this liquid. If it's at high velocity, the little tiny nanoparticles have a difficult time passing around the object because of the speed. And they get dragged along with it and, in fact, compressed by the incoming object. And what happens is it forms a rigid structure, essentially, and it prevents penetration. But if you do it slowly, as you can imagine, if I put this object in very slowly, what happens is these nanoparticles move around the outside, and they don't impair the object's ability to be able to penetrate the liquid. They've been able to create a material that you cannot penetrate with a sharp object. In other words, if you take a knife or an ice pick and you try to go through it, you cannot go through it.
Materials are being developed today that will also provide dynamic camouflage as soldiers move from one environment to another.
One day I'm in the mountains of Afghanistan and it's a mountainous terrain where colors are gray and not very abundance of trees or whatever it might be. The uniform's literally mimicking the mountainside. Whereas the next day I need to go into an Iraq area and into the city area, and now the uniform's mimicking the buildings that are behind me, the cars that are behind me, the folks that are behind me. This is all going to be used through this nano-based technology.
You can easily incorporate a variety of sensors and embed them in the soldier uniform where you can monitor the pulse rate, the heart, breathing, whether a soldier is detected in a horizontal position on the ground. We have a sensor that's monitoring the soldier's breathing and heart rate and so on. And from that, the uniform automatically applies CPR to the soldier to keep the soldier alive. Then that information gets transmitted over the network to a medical unit that then knows where the soldier is, knows the condition of the soldier, is monitoring the soldier as they're going out and trying to help the soldier and keeping the soldier alive.
At dawn, the battle begins. Or so it has since time beyond memory. wars have always been fought in daylight. But over the past several decades, a new technology has changed all that. Scientists have discovered ways to capture available electromagnetic radiation outside that portion of the spectrum visible to the human eye. They've developed equipment to enable the soldier to fight come nightfall. How do night vision goggles work? They are electro-optical devices that amplify existing light. Although it may appear dark, there is usually some level of ambient light, either from the moon and stars or from distant man-made sources. Image intensifiers capture this light and amplify it thousands of times over to display the battlefield to a soldier. The goggles are tuned to a broad spectrum, from visible to infrared. In fact, sight doesn't come to soldiers directly, but from the electronic image projected on a screen. Why green? Because the human eye can differentiate more shades of it than any other color. There's also thermal imaging. This works by detecting the temperature differences between an object and its environment. Where ambient light won't cut it, heat gives combat vehicles and helicopters their eyes on the prize. But goggles that see in the night are just the beginning. New advances in flexible display technology will make it possible for the soldier of tomorrow to see the entire battlefield projected on their visors.
The soldier's visor will be pulled down and they'll have a complete display where they'll be able to look at data, understand what's going on.
In the future, a soldier's visor will show them Blue Force tracking information and GPS coordinates for target acquisition. In conjunction with laser pointers built into their rifles, it will also allow them to target and transmit GPS coordinates to the network, and to call in fire from miles away. Imagine if you were able to unroll your laptop. Imagine if you could fold up your computer and stick it in your pocket. Imagine what it will mean for warfare.
This is really a technology revolution in displays.
So you can imagine that you'd have inside of a command and control vehicle a screen that would just pull down from a roll, and you'll be able to view the entire battle space on that screen. These things are within our grasp.
The soldier today carries 150 pounds of things, and if you give them a glass-based display, you say it's a big display that gives you lots of information, he may just leave that behind, or she, just because of the weight issues. But offering them a compact, lightweight, rugged display, really will provide them unique opportunities.
You're aware, of course, of the last technology revolution when we went from the large, bulky cathode ray tubes deep to a thin, flat panel glass-based display. That enabled all kinds of new applications for displays that we didn't have previously. We now carry around displays in our pockets, cell phones and the like. They appear in our automobiles and so on. The idea is to put the display on a lightweight, flexible, rugged substrate. This particular display technology is called an electrophoretic ink. You see it's black and white. You see the images moving through, cycling through here. This small device can carry about 2,000 images, or display about 2,000 images with only a few AA batteries. So it's very low power. One of the advantages of this particular technology, and one of the reasons we're very interested in it, is because it is intrinsically low power. And of course that enhances the portability. So we've already shown this technology in a kind of a rugged but semi-flexible format. It's not completely flexible, but certainly more flexible than glass. And so the idea is that we want to transform this technology completely over to full flexibility. Another technology shown here is it's a cholesteric liquid crystal technology. It's not the same liquid crystal as you find in your notebook computers and your cell phones, but it's a similar liquid crystal technology, but has the advantage over this kind of liquid crystal in that it's like this material, very low power. You only have to add power to this particular display when you change the image.
By 2025, soldiers will be rigged with computers and weapons battle suits and vehicles that are almost beyond imagination. Just in time for soldiers to sit out the war and let machines do the fighting for them. The ultimate soldier will be a robot.
Right now, most of what we call robots are really just teleoperated machines. People are driving with joysticks. We're continuing to develop robotic vehicles that are going to have increasing degrees of autonomy. Initially, these autonomous robots are going to be doing relatively mundane tasks, autonomously operating unmanned air vehicles, surveying the battlefield, robotic cargo trucks driving along in big caravans where there's one person in one of the vehicles and the rest of them are robotic followers. Over the next decade, I think we're going to see increasingly high levels of autonomy in our robots where they're able to think and act for themselves.
Robots are being used today to keep soldiers out of harm's way.
A major problem in Iraq is trying to provide standoff distance between the soldier and the threat at checkpoints. What we are trying to do is provide a robot where he can stand behind a concrete bunker, run that robot 50 meters or 50 yards out to the vehicle, run the robot under the vehicle, and do the under-vehicle inspection, and have the cameras, everything's on board, the imagery is transmitted back through a Wi-Fi network, so he can examine the vehicle at a safe distance. We've already have a prototype mast. This mast can go up and down, it'll approach the vehicle, it'll instruct the operator and tell them to get out of the vehicle, open up the doors, open up the trunk, and then we can move the vehicle, the robot, around the vehicle and look inside and make sure there aren't any large objects, or if there's a huge amount of explosive in the vehicle, we're going to see it.
Imagine a soldier that never gets tired or hungry, who can face the greatest danger without blinking an eye. The age of the BattleBot is already underway. The Talon robot was originally designed for reconnaissance, sensing, and explosive disposal. It has now been turned into a mobile fighting machine, armed with anything from an M16 rifle to a 6mm rocket launcher. This mobile weapons system can be remotely operated from a mile away, and it's now become a valuable force multiplier.
Well, if you look at our situation in Iraq and Afghanistan now, the problem is there's such a large area to cover, and there's so few soldiers. And so we need to leverage soldiers. We need to leverage personnel. We need to automate the process of physical security and force protection. And so having a robot out there and having that robot be fairly inexpensive means it's expendable. And then, of course, we can leverage a swarm of robots that are doing physical security. In other words, we can cover a lot more area with a few people and do a much better job of protecting our assets. And this will be a combined scenario of the UAV, unmanned air vehicles, working in synergy with the ground vehicles. That will give us the leverage we need to combat some of these very difficult, unpredictable, guerrilla-type war activities that we're currently fighting in the world.
Close to home, robots have already seen action. Days after 9/11, the PackBot robot was deployed at Ground Zero. In those dark hours of suspense, it spared engineers the risk of surveying the damage to the basement of the Marriott Hotel. PackBot gave us a glimpse into the future and quietly launched a revolution. Soon, robots will not only save lives in disaster's wake, but on the battlefield as well. The latest advance, remote-controlled triage.
The mission of our command is really to take a look at the soldier who's injured on the battlefield in those first moments after injury, and to provide the technology to enable the first responders to be able to preserve that soldier's life until they reach a tertiary care facility or a hospital facility to provide more definitive care. On the future battlefield, it'll be much more dispersed. There'll be fewer medics per individual soldier. So the distance between the medic and the soldier in the hospital are all be increasing. So we have to provide the technology for that far forward injury.
Throughout history, we've lost a lot of medics in combat trying to rescue a patient or other soldiers. So in the type of warfare we're in now, we're looking at how can we rescue a casualty under fire or in a contaminated area from chemical and biological weapons. This PackBot robot that can go out and tow this sled to the casualty can roll on it, and then it has a series of ropes and so on that they can pull the casualty back to safety. This large vehicle is a robot built by Robotic, a Northrop Grumman company, that's called the Tactical Automated Ground System. And then there's a smaller robot called the Andros. So essentially, the concept is that this smaller robot is equipped with sensors, chemical sensor for blood and nerve agents, industrial gases. There's one for radiology, and we're going to build one for biological sensors. It can go out with all the sensors on it that I described before, and eventually we'll be able to pick up a patient and bring them back. When you take these technologies and mount them on their robot, the robot can go into an area, determine, is there a patient there? Is he alive or dead? What is his physiological condition? Is there biological, chemical, or radiological contamination in night or day using the other camera and so on? and then they're able to go and rescue the patient with that robot.
The idea behind this life support for trauma transport platform was that we could provide an autonomous ability to take care of the patient. The medic could do things like place IV lines and put in ET tubes and endotracheal tubes to help his breathing, and then place him on this life support system. This system would be monitoring all his medical parameters, his physiologic parameters, and that information then would be fed back to the therapeutic devices that are breathing for him. For example, this ventilator would be adjusted automatically to optimize his ventilation.
High tech as any war may be, the casualties will always be all too human. The goal of technology is to keep losses to a minimum. The new technology of war offers soldiers an even greater advantage, a superiority that extends to every branch of the military.
Jointness is mandated by a law in 1986, the Goldwater-Nichols Act. But we're seeing that the Department of Defense wisely and the Congress are even moving beyond just Goldwater-Nichols, wanting to create more and more joint enterprises and joint operations and joint commands, because this is more efficient, it's more cost-effective, and frankly, it's more effective on the battlefield. If we assume a new paradigm, and that is the paradigm of shorter, more intense wars, more frequent wars.
Where we're headed is even more technology that's born joint, that is designed to be used by the force as a whole. Key there are things like our electronic systems and our communication systems that allow us to cut across the traditional boundaries between the services and apply the best force from whatever the source is among the services who are present to support the conflict.
I think if we compare Iraq's war with Iran in the 1980s with America's most recent war with Iraq, we understand the difference in technology between the American military and a conventional military. Iran fought Iraq for nearly a decade. They had hundreds of thousands of their soldiers killed, and at the end, it was a draw. The United States fought Iraq's military. It took us a couple of months to get ready, and in the end, there was no contest. The biggest obstacle that we faced was a sandstorm. So I think that it speaks to the utter disproportion between America's military capability and that of any other military on the planet.
Will future technology be a future deterrent? With robotic weapons, a remotely controlled field of battle, and fully integrated networks that better support and protect soldiers of tomorrow, enemies around the globe may indeed reconsider the repercussions of armed conflict. But when needed, the new technology of war will be armed and ready.